Assalamualaikum. My name is Nazihah Binti Jafardin and my matrix number is CF230187 and I will be explaining about the calculations of the part analysis.
Hi, Assalamualaikum. My name is Mohammad Fadli. My matrix number is CF230146 and I will continue with conclusion.
Hi, my name is Aleya Binti Azman. My matrix number is CF230138. I will explain about methodology.
Hi, Assalamualaikum. My name is Binti Kahar. My matrix number CF230171. So I will continue about area of study.
Hi, Assalamualaikum. My name is Binti Aras. My matrix number CF230144. So I will explain about problem statement.
Hi and Assalamualaikum. My name is Asyaraff. Azizi. My matrix number 230153. I will explain about the objective for this project.
So I will explain area of study. The study is conducted at Perwira Residential College, Balik Raja, Johor. As shown in figure 4, we conducted and analysed the piping system for one building only at Perwira. Therefore, this field of research is a suitable one for a serial pipeline analysis. We conducted this project together to calculate the amount of energy loss, the difference in height, or the pressure difference for the selected system.
Okay, I will explain the objective of this project. The objective of this project is to calculate the amount of energy loss, the difference in height, or the pressure difference for the selected system used for fully residential school and hostel facilities building.
Problem statement. In the realm of fluid mechanics, the focus of this project is to evaluate and quantify critical factor impacting the performance of selected system within the fully residential school and hostel facilities. In this case, Perwira. The primary objective are to calculate the extent of energy loss, identify height difference affecting fluid flow and assess pressure variation within the system. By addressing this fluid mechanics challenge, the project aims to enhance the overall efficiency, sustainability and functionality of the fluid-based infrastructure supporting this residential.
Okay, I'm Aisya Binti Azman and I will continue about methodology. Type of fluid flow in the pipe has been identified using the Reynolds number formula. Formula laminar flow, if the Reynolds number is less than or equal to 2300, it is a transition flow. If the Reynolds number is between 2300 and 4000. For turbulent flow, if the Reynolds number is greater than or equal to 4000. Okay, this is a formula for Reynolds number. And then second, the velocity in the pipe is calculated using flow rate formula. This is a formula for flow rate. 3. Area of the diameter of pipe is calculated using area of pipe pi d power of 2 over 4. 4. Friction is calculated using Moody diagram with formula. This is formula for friction, E over D. Assume formula pressure of tank is A, pressure 1 and B, pressure 2. This is number of pressure 1 and 2. Okay, next, why our group assume the value? It is most likely based on design consideration and industry standard that a 1000 gallon tank operates at 30 psi and a 1500 gallon tank at 60 psi. Temperature is affected by its volume, temperature and intended use, among other things. In general, larger tanks may need higher pressure ratings to handle the percentile demands and increased volume. Practical factor such as the tank height may also have an impact on the relationship between pressure and tank size. Okay, it is because of the weight of the liquid, the tank bottom pressure increase as it height thus. Higher pressure rating may therefore be necessary for larger tank to continue operating. Specific value mentioned are example and may vary depending on the application and engineering specification.
So we start with the calculations. For calculations, the information that we have is flow rate, which is 120 liter per minute, and converted to meter cube per second, we will get 2000 meter cube per second, and first diameter, second diameter, and third diameter. All of the unit we have to convert to meter. Second step is we have to calculate the Reynolds number. So the formula that we use is Reynolds number equal to rho VL over kinetic viscosity. So this is the Reynolds number that we get, and the type of flow of our pipe is turbulent flow. There is a few value that we assume, which is kinematic viscosity, velocity 1 and velocity 2, pressure 1 and pressure 2. The reason why we assume the value is because they didn't state the actual measurement or the actual value at the site that we study. For example, at the tank, they didn't write any velocity or pressure, hence we have to assume the value refer from the standard value. So because our pipe is 0.0, hence we have to plot at the Moody diagram to get the F, to calculate the F. So our pipe is 0.0 because it is plastic, poly pipe. We have to plot at the Moody diagram, and then we will get the actual value, which is 0.0081. After we get the value from the Moody diagram, so we can calculate, finally we can calculate the friction factor using the formula E divided with D, which is diameter. The reason why we chose 0.063 diameter instead of the other two diameter, because this is only to calculate the friction factor from the Reynolds number diameter. So the friction factor that we got is 0.0081 from the Moody diagram. Last part is to calculate the actual calculation using Bernoulli equations. So our group used Bernoulli equations to solve the pipe analysis. So the formula is P1 over rho G plus V1 square over 2G plus Z1 elevations equal to P2 rho G plus V2 square 2G plus with Z2 and HL. HL included of HM, minor loss, and also HF. So now we can substitute all the value to the formula. So this is our assumed velocity, and this is the pressure tank that we assume, which is converted from PSI to Pascal, which is this one, this value. And then now our HL is equal to 36.26 meter. So the last part, finally we can calculate for the heat loss, which is HF, heat loss due to the frictions. Formula of heat loss is HF equal to FLV square D2G. So depending on our pipe sketching, we have 3 HF, which is the first one, second, and third. So after we get all the length that we measure from the site or area of studies, now we can substitute all the value into the formula. So our total for HF is 0.45. And finally, we can equal the formula to HL equal to HF plus HM, which I have explained before. HL included the HM and HF, so that we can get the HM, which is minor loss, is equal to 35.8 meter. So that's all for the calculations of our pipe. Thank you.
In a conclusion, our project on residential water demand utilizing the Bernoulli equation has provided valuable insight into optimizing water supply system. By applying the principle of fluid mechanics, specifically the Bernoulli equation, we have gained a comprehensive understanding of the factor influencing residential water demand. Second, throughout our analysis, we have identified key parameters such as pipe diameter, elevation change, and fluid velocity that play crucial roles in determining the pressure and flow characteristic within the water distribution system. The utilization of the Bernoulli equation in our project has not only deepened our understanding of fluid mechanics but also practical implication for real-world application. In a summary, our project has successfully demonstrated the relevance of fluid mechanics, particularly the Bernoulli equation, in addressing residential water demand. The insight gained from this study contribute to ongoing effort to develop more efficient and sustainable water supply system for the benefit of both present and future generation.